Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. Principal Component Analysis, or PCA, is a way to visualize multidimensional data in fewer dimensions. To understand PCA, let's first try to understand what multidimensional data mean, or what is a dimension in data. So data is basically a set of points with features associated with them, and every feature of the data is a dimension of the data. Let's even break it down further in some simple terms. Let's take an example of a class of 20 kids, and we want to see the data of this set of this group of 20 kids. So one feature of this group could be names of the kids. Another feature of this data could be heights of all kids. Third feature could be weights of all kids. Fourth feature could be the gender of the kids. So when we try to visualize this data in a Cartesian coordinate system, we can visualize this data on every on dimensions of the Cartesian coordinate system. So if we are only looking at one single feature of this data, let's say just we are looking at only the heights of kids, we can plot that data on one single axis. Correct? So think of a ruler where we are just marking the different heights of different kids. So it's just one axis. Now if we add another feature to this data and we want to plot that feature to visualize the data, let's say we add another feature as names of kids, so then we can have one axis of the Cartesian coordinate system to have names, and another axis which is perpendicular to that axis could have heights, and we have a two-dimensional data because we are using two features of this data. Let's add another feature which is weights of kids. So now we can plot this data in three dimensions, correct? Because we are using three features: names, heights, and weights. Up to this point, it is easy to visualize this data because the data has been either one dimensional data, two dimensional data, or three dimensional data. But let's say if we add another feature to this data, which is genders of kids, we can't visualize this fourth dimension in this three-dimensional Cartesian system. That's because as human beings, we cannot visualize anything greater than four dimensions. So that's why if we have multi-dimensional data, it's important to visualize this data into fewer dimensions so that we get information from the data. Now, in this particular examples of group of kids, we only talked about four features and 20 kids. But in real life example, we could have millions and millions of data points with millions of features for each data point. And in that situation, we are then faced with a problem of choosing the right feature so that it gives us the most information about the data. So before we move forward, we need to understand the difference between data and information. So data is basically raw data. It's blank, it's facts. It doesn't give you any information, it just gives you facts. When we analyze the data, we extract the information from the data, and then the information that we extract are basically the conclusions or correlations or something that we get out of the data. The goal of data science problems is to extract maximum information from the data in minimum effort. That's basically the engineering part of data science. And we will visit this phenomenon of extracting maximum information with minimal effort in many data science problems in this podcast. And PCA is no exception. We want to extract maximum information from a multidimensional or multi-featured data. And for that, we need to choose the features that give us the most information of the data. Now, how do we decide which features give us the most information? So for this, let's take an analogy of a picture of a tree. So let's say we have a photo, a digital photo of a picture, a digital photo of a tree. Let's say if every single pixel in that picture is of the same color, can you tell by looking at that photo that it is a picture of a tree? No, you won't be able to, because it will be a unicolor or a monochromatic, or basically a square with same colored pixels in everywhere. So you won't be able to extract the information that it is a picture of a tree. If you add some information to this, for example, whichever pixels are dark, we add some luminance value to those pixels, and whichever pixels are light, we add some low luminance value to those pixels. And basically we create, let's say, a black and white image of this picture of a tree. Then you can guess from looking at that picture that it is a picture of a tree. Why could you do that? Because instead of all pixels being of the same value or same colors, the pixels are of different luminance, and because of that you could identify that it is a picture of a tree. Now if you add more information to this, instead of being just instead of the information in the pixels being just the luminance, if you add color information to this, then you would be able to even get more information from the picture. So let's say if the tree is green, you could possibly say that the photo is taken in spring, or if the leaves are yellowish, then you would be able to say that the picture is taken in the fall. So you extract more information when you add more values to the pixels of that picture. So the feature that gives you the most information from the data is going to have a widest range of values. If the values of the feature in the data are the same, that feature is not giving you the most information about the data. The feature that has the widest range or the maximum variance of the values, that feature will give you the most information about the data. And what principal component analysis does is identify those features which have maximum variance. The principal component in the principal component analysis is the feature that has the maximum variance. Now, how does PCA or principal component analysis actually find out the features that have the most information is a subject of another episode. But what we need to understand is PCA or principal component analysis helps us visualize the data into fewer dimensions that can be comprehended by humans by either visualizing this data in 2 dimensions or 3 dimensions. A multi-dimensional data uh, scaled down into fewer dimensions. Thanks. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.